all a secret. So, we're going to learn about quadratic expressions. So when I use the word quadratic, do you know what that means? That's a quadrilateral, 4 sides.
So this will have 4 points.
You know, that is, I guess, a common misconception. I never really thought of that. Quadratic thinking for something, but that's not actually what it means. A quadratic expression means that you're going to have an x squared term in your expression. So it's just an expression with x or any variable really that has a squared term. So a squared, x squared, b squared, whatever the case might be. That's what a quadratic is. Now, that right there, I have expand, x plus 2 and x plus 9. Do you remember how to expand those binomials?
Yeah, maybe.
Product?
Isn't it like x times x and then x times 9?
Yes, that's exactly what it is. I get this isn't in your book, but what I learned back home is this. FOIL. First, outside, inside, last. So what that means is you multiply the first terms together, so x and x. Then you multiply the outside terms together, which is x and 9. Then you multiply the inside terms together, that's 2 and x. And then the last term, which is 2 and 9.
Isn't this the rainbow?
Looks like.
Last year. Oh, we did it! I did it last year.
Well, yeah, you should have done this last year because I went over it with my aides.
I was calling the rainbow.
Okay, well, this is what I learned
Wasn't there when you guys-
was FOIL. But whatever rainbows, if that's what you prefer, go with the rainbow. But as long as you realize how it works is you have to make sure that you multiply each term in the first set of brackets with each term in the second. So x times 9, 2 times x, 2 times 9. Right? You just have to make sure you make those multiplications. A good way, if you tend to forget or get confused, is to actually draw the line showing which ones you've already multiplied. That way you don't make a mistake and multiply the same one twice.
But do you just like add them together at the end?
Mm-hmm. Exactly that.
So it's 2x plus 11.
So this would give me, what is x times x?
X
X
squared.
to the power of 2.
Woo! X squared
Got the square.
plus, then I have x times 9,
That's 9x.
9x, 2 times x, and 2 times 9,
Oh no. Never mind. I was adding them.
18. So you just multiply them out like that. So when I say expand, that's what I mean. Now, once you've expanded them, then you have to simplify it. So
So for x.
we have to collect like terms. So these two terms here,
11x.
put them together. Yeah, that's all. So we have x squared plus 11x plus 18.
So that's all.
That's all. We're not solving it. We're not finding values for x, nothing like that.
Also, we don't do the 18 on the other side. So
Nope. Because it's an expression. It's not equal to anything.
Oh,
So since it's an expression, you can't actually solve for
okay.
anything.
So it's not equal.
If this was, this is equal to 0, then I could solve for x. But with the way it is now,
No.
I can't. Okay? So that would be it. When I say expand and simplify, I want you to do this. Yes, it is.
Can we just do this?
Compared
Try
to
one.
the other thing.
Another.
Minus.
What?
Okay.
I got x to the power of
Let's see what it is.
minus 7x.
So, what do we start with here?
X times
X.
Which is?
X squared.
minus
Yeah.
7. It's negative.
Okay, so I have x squared. What's next?
X times 6.
Which is?
6x.
Okay. Ladies, what's next?
It's negative 7 times x.
Which is?
Minus 7x.
And the last one?
Negative
Minus 42. Yeah.
Exactly.
And then you have to simplify.
And then you simplify, which gives us x squared
Minus
minus x minus Not too bad, right? Expanding, simplifying, easy stuff. Or so you may think.
Are you gonna make it complicated now?
Not much more complicated.
No.
But yes, I am.
3M.
Let's go together, okay?
Okay, so after we decide where things are going to be, what's this question?
Wanna be my parent?
Okay. Hansa, Carlos, you two go together.
Yeah.
Shay and Anna, Sophie, Kate, done. We're good to go. Marco's left in the dust. So, what do we get from this?
Disadvantages for
It's
kids.
easy.
It's easy.
Can I say?
Okay, so what's the answer?
6n squared negative 11m plus 4.
Did everyone get this?
Yes.
Sure.
Almost half of it.
I got -12. Oh, you simplified it already. Okay, yeah.
I simplified it right away. So 3m times -1 is -3m. And -4 times that is -8m. So that would give you -11m. So you might have just made a small calculation error.
Yeah.
For some reason, I have minus.
-4.
I don't know.
-4.
That's why I suggest doing this so you don't accidentally multiply the wrong things together. Right? Like actually showing what you multiplied together so you don't make the mistake.
So it's first with last. No, first with first.
First two terms, the outside terms, or sorry, I guess your perspective. First terms, outside
Outside
terms,
terms.
inside terms, last terms.
It's a foil.
It's a foil. Okay, so we know how to expand and simplify. But now we're going to talk about the hard part, which is doing the opposite, which is factoring. And to make it
I like
easier,
this.
I'm going to use this one, 6m squared. So we already know what this is going to factor to. And now that I realize I did that, I'm going to change my mind. And I'm going to use...
This is now like an American school.
No, I'm going to use this one instead. X squared minus x minus 42. Okay. There's a reason why I picked that example over the last one, because it'll actually be easier. So again, we know what this is going to factor into because we've already... Why does that keep We've already solved it, right? We took this, expanded it, and got this as our answer. So now I want to work backwards. I want to take this and end up with this here as my answer. Okay? So how we do that? Whenever you're factoring, at least an example like this, where there's nothing in front of the x here, right? There's no number in front of the x. The best way for you to do this is to actually start off by writing out what it's going to look like in the end. So in the end, it's going to look like this. X, some number, x, another number. We don't know what those two numbers are yet. That's what we're trying to find. So this is how it works. You need to find two numbers. And these two numbers, which in this case, we'll just call them A and B. Okay? A plus B must give you whatever's here. In this case, -1. And then A times B must give you whatever's here. In this case, -42. So you need to find two numbers that multiply together to give you -42, but add together to give you -1. So the way to do this is you're going to take -42 and write out all of the factors of -42. That is, 1 times 42, 2 times 21, 3 times 1, 12, 13, sorry, 14. You don't know what I'm doing here?
No. Why?
1 times 42 is 42. 2 times 21 is 42.
It's negative.
I know, I'll get to that. But you know these equal 42, yes?
Yes.
Okay.
Yes.
4 does not go into that evenly, so we're going to skip that. So the next one is 6 times 7. Okay. So first thing I did is I wrote out all of the factors of 42. Now, because I know that it's a negative 42, one of these numbers, whichever one it might be, has to be negative, right? Because in order to get a negative answer when I'm multiplying, one number has to be negative, one number has to be positive. Okay? So I need to look at these and see which one of these numbers will give me a difference of 1. So if I subtracted these from each other, would I get 1? No. If I subtracted these from each other, would I get 1? No. If I subtracted these from each other, would I get 1? If I subtracted these from each other, yes, I would get 1. Exactly. So these are the numbers I'm going to use, 6 and 7. So the last part I need to do is just decide which one of those numbers is going to be negative. Is the 6 negative or is the 7 negative?
7.
The 7 has to be negative.
Why?
Because if I take 7 minus 6, that gives me a positive 1. But if I take 6 minus 7, that gives me a negative 1, which is what I'm looking for. So this is my negative number. So then when I have what I started with up here, I can take out these letters and put in the actual numbers. So plus 6 and minus 7.
That's cool.
It's cool for now.
I'm still confused.
That's fine. You'll figure it out. Let's try another example. Which is not going to work. Oh, where'd my other example go?
I think she taught, like, she showed me this last time.
There we go.
This was last year.
So I'm going to try another example here. I have x squared plus 7x plus 12. So remember, what I'm trying to find are two numbers that multiply to get 12, add to get 7. So what's the first thing I need to do?
Wait, so add to get 7 and multiply to get what?
12. So what's the first thing I need to do?
Write the x out.
Okay. Yeah, let's start there. I wasn't sure what you meant by write the x out, but I figured it out. So yes, we write out what we're looking for there. And then what's next?
You do the thing you did last time?
Yes, which was?
Factorize 12.
Write out the factors of 12, exactly. So what numbers multiply together to give you 12?
2 times 6. 1 times 12.
2 and 6, 1 and 12,
4 and
3 and 4.
Woo.
Or 4 and 3, same idea. Okay, so which of those pairs of numbers would I add together to give me 7?
3 and 4.
3
Is
and
it
4.
always the smallest one?
Nope, it is not. It just happens to be in this case. And since this is positive, I know these are both positive. And since this is positive, I know that I'm just going to add them together.
Yes. Woo.
Does it matter if you put 4 first or 3?
Nope, it does not matter. You don't get it? You think you get it.
Is it like you
Following?
Always, you always do this thing with the 2 times 6, 1 times 12 with the number that has no x in it?
Yes, with the constant term that's by itself.
What? Yeah, I get it.
The number that you write the factors of is always the number that's by itself. So without an x term.
What if there's more? Yeah, but what do you do with the 7?
Like, what do you mean, more terms?
Yeah, what if it would be like x to the power of 2 plus 7x plus 12 plus 4?
You would add 12 and 4 together first to get 16 and then go through it.
What if it was like 6, like when we had 6m squared plus minus?
See, we don't actually get into that at all, which is why I skipped it. When you get into that, we do this thing called decomposition, which is a lot more complicated than this. But you won't we'll get to that later in the book if we get that far this year. Because I know I went over it with my HS2s, but we might not have to cover it this year. We might do it next year. For now, we just stick with the basic one. One more. Give this one a shot.
I think I get.
Okay, who wants to do it?
Yeah, I guess.
I can tell you your answers are correct, so who wants to do it?
Yeah, I guess I will.
Hansa? Okay. There you go.
Thank you.
You're welcome.
So, should take this number right. Can I just write it like this, or do I have to?
If
put
you want,
in
that's fine.
brackets?
That's fine.
Well, I took these numbers.
Yep. You can circle them.
And then I have my. And then I'll put that numbers there. Oh wait, this is plus.
Perfect. Couldn't have done it better myself. Although my writing is just a little smaller, but otherwise. So yes, exactly right. We have negative 16. Wrote out our factors. We found that this one would give us a difference of minus 6. So 2 minus 8 is negative 6, and 2 times negative 8 is negative 16. Yay. So, how do we feel about this?
Or can we do it tiring?
It is tiring. So you want another example? I don't think I have one here, so I'll make one. Okay. X squared minus 8x plus 15. Factor that. But you weren't part of the conversation. So, I heard it. We got this one. So factors of 15. 1 and 15. 3 and 5. And then I picked this example for a reason, because this is the tricky one, which you all eventually figured out, is this is a negative 8, but this is a positive 15. So your first thought is that one of these should be negative to do this, but that doesn't work, because then you have a negative answer here. However, you can make both numbers negative, because 2 negatives give you a positive when you're multiplying. So x minus 3 times x minus 5 is correct. Okay. So are there any questions about this?
Can we do another one?
No.
Sure, there's all kinds in the book. Tomorrow I will cover the very last section of quadratics, which is quite small, so it won't take too long. And then we will have our test next week sometime.
Is it gonna be surprising?